Hi, this is Mr. McWhorter. Thank you for joining me. Let's get ready for the Unit 4 test of Algebra 1. If you haven't done so already, go ahead and pause this recording and download and print out the study guide from the Unit 4 page in Open Class. Jamar says that the slope of the line passing through 2, -4 and 3, 6 is equal to the ratio -4 minus 6 over 3 minus 2. Well, first question is, did Jamar use the correct method to calculate the slope? Well, the formula for slope is the difference of the y values over the difference of the x values. So y2, it looks like he's doing y2 and x2 for this point, x1, y1 for that point. So y2 minus y1 is -4 minus 6. So far that looks good. And then x2 minus x1 would be 2 minus 3. Uh-oh. That's 3 minus 2. So, no, Jamar did not use the correct method. He reversed the subtraction of the x values. So what is the slope of the line that passes through 2, -4 and 3, 6? Well, Jamar was almost right, except on the bottom it was supposed to be 2 minus 3. If we're doing -4 minus 6, then we need to do 2 minus 3. Well, -4 minus 6 is -10, and 2 minus 3 is -1, and -10 divided by -1 is 10. So the slope of the line that passes through those points is 10. Find the slope that passes through each pair of points. Okay. So we need to do the y value minus the y value over the x value minus the x value. So 3 minus -4 over -4 minus 2. Notice since I started with this point when I subtracted the y's, I have to also start with this point when I subtract the x values. 3 minus -4 becomes 3 plus 4. Subtracting a negative turns into addition. -4 minus 2 is -6. 3 plus 4 is 7. So we got 7 over -6, and that is -7/6. Alright, over here. The y minus the y. Now I'll go ahead and, since 15 is bigger than 3, I'll just start with, I'll do 15 minus 3 on the top. So the y values on the top, and then 2 minus -2 on the bottom. And whenever you subtract a negative, it turns into plus. So 15 minus 3 is 12. 2 plus 2 is 4. And 12 divided by 4 is 3. Uh-oh, this one has decimals. That's crazy. Well, this one is bigger than this one, so I'm going to subtract in this direction. So on the top, 4.37 minus 3.37. And on the bottom, I started with this point, so I'm going to have to start with the -7 minus 1. Now this kind of works out nicely for me because the 0.37 minus 0.37 is 0. So 4.37 minus 3.37 is 1. -7 minus 1 is -8. 1 over -8 is -1/8. So now, do the following sets contain 3 collinear points? So if these 3 points are collinear, that means that the slope of line AB is going to equal the slope of line AC. Because imagine if you have a point A and it goes to point B along a certain slope. Well, say if you have point C has the same slope coming out of A. So that means that you're leaving A at the same trajectory and eventually you're going to hit C. If AB and AC have the same slope, since they both go through A, that means that B and C are on the same line. So what is the slope of AB? Alright, the slope of AB, we're just going to use these points. 2 minus 1 is the y value minus the y value. And then starting with the same point, 1 minus 3. So 2 minus 1 is 1, and 1 minus 3 is negative 2. So the slope of AB is negative 1/2. Now how about the slope of AC? That's going to be 2 minus negative 1. The difference of the y values on top, and then 1 minus 6 on the bottom. 2 minus negative 1 is 2 plus 1, which is 3. And then 1 minus 6 is negative 5. So that's negative 3/5. And since these two slopes are not equal, that means that we're coming different directions out of point A to get to points B and C. So no, A, B, and C are not collinear. But what about X, Y, and Z? You can totally tell there was never a typo here. But ignoring that, we're going to use the same logic. The slope of XY needs to equal the slope of XZ in order for these 3 points to be collinear. So the slope of XY, y value minus the y value. So negative 3 minus negative 2 turns into plus 2 over negative 2 minus 0. So negative 3 plus 2 is negative 1, and negative 2 minus 0 is negative 2, and that is a slope of positive 1/2. What about x to z? Negative 3 minus negative 1, so minus negative 1 becomes plus 1, and then negative 2 minus 2. Negative 3 plus 1 is negative 2, and negative 2 minus 2 is negative 4. Negative 2 divided by negative 4 is positive 1/2. So we can conclude that yes, x, y, and z are collinear. Does the point negative 1, 5 lie on the graph of y equals 4x minus 1? Well, an easy way to figure that out is to plug in the x value and y value that we're given and see if it satisfies the equation. So the y value is 5, so I'm going to write 5 equals 4 times the x value is negative 1 minus 1. So 5 equals, so 4 times negative 1 is negative 4. And then negative 4 minus 1 is negative 5. And we see that these are not equal. So this point does not satisfy the equation. So since negative 1, 5 does not satisfy the equation, it is not on the graph. Using your knowledge of parallel lines, create equations of two lines that are parallel to y equals 2/5 x minus 3. So part 1 is to graph this equation on the coordinate plane provided below. Now we need to start, when we have it in slope-intercept form, we start with the y-intercept. and that's right down here on the y-axis at -3. Then we use the slope to move, and slope is rise over run. So our rise is 2, and it's positive, so we're going to go up 2. And then our run is 5, and that's positive, so we're going to go to the right 5 and mark this point. Now that we have 2 points, we can draw the line that goes through them. So now we're going to write 2 equations of lines in slope-intercept form that are parallel to the graph of the line in part 1. Now all we need to do, in order for lines to be parallel, they have to have the same slope. So we have to make sure we have 2 over 5x. And then we can put any other y-intercept we want. We could have a y-intercept of 0. Or we could have a y-intercept of positive 3. So the one with a y-intercept of 0 would be right about here. And the one with a y-intercept of positive 3 would be right about there. And then explain why the equations of the lines are parallel. Because they all have the same slope. So now point slope form is like this. Y minus the y value of a point equals the slope times x minus the x value of a point. So all we have to do here is we plug in for our slope and for our x value and our y value. So y minus the y value, which is -19, equals the slope, which is -11 over 7, times x minus the x value, which is 35. And then minus a negative is plus, so this is y plus 19 equals -11 over 7 times x minus 35. And now using the equation we wrote in part 1, we're going to write an equation of a line that is perpendicular to this line. So perpendicular means that the slope is the opposite reciprocal. So if your slope is a whole number, it's -1 over that number. If your slope is a fraction, you change the sign and then flip it over. So we could even have it going through the same point. So we can leave the y value of the point and the x value of the point alone and just change the slope to be perpendicular. Opposite of negative is positive, and the reciprocal of 11 over 7 is 7 over 11. So here is a line that's perpendicular to the line from part 1. So why don't you go ahead and stretch, take a little break, get a drink of water, maybe a snack, and then come back and meet me for part 2. Thanks a lot. See you soon.